Hi everyone and welcome to the second day of the Advent of Python. So today we will learn about Python dictionaries and we'll solve the Advent of Code challenge of the day 2 using them. Okay, so here I have the Advent of Code page. Let's see the day 2, what it's about. And I also have here the Visual Studio Code with our repository of the Advent of Python. So I will also create here the second day notebook, day 2 dictionaries, let's call it, IPy notebook. Okay, also I will put here with markdown. So if I press the letter M, this is a markdown cell. So now I can put here some titles. So I can write in markdown in this format, and then with Control Enter, we can see here a better title. Okay, now below this one, I will create a new code cell, this in Python cell. Okay, let's start here with dictionaries. So Python dictionaries are another type of structured data type, similar to list, and also we have sets and tuples built in. But the difference between dictionaries and lists, for example, is that in lists we were accessing to every element with the index of its position in this list. So the first element had the index 0, the second element we access to it with the index 1, and so on. So here we will store every element with a key, and every value of the dictionary will have a different key. So for example, if I create here my dict, this is my dictionary, we declare them with curly braces, and then I have to put here the key with quotes, and this will be the key 1, for example. It can be a string or an integer, for example, the key, and then with a colon I can put the value. So let's put here a string, value 1. So the value can be any type of object of Python, so strings, integers, floats, or other lists, other dictionaries. Everything can be a value of a dictionary. And then I can put the second element separated with a comma. So this will have the key 2, for example. This can be any string, I repeat. And then colon, and let's put here the integer 2, for example. Then next element separated with another comma, key 3. And I can put here a list, for example. Let's put here a list. Okay, this could be my dictionary. Let's see it here now. Okay, so this is my dictionary. We can see that it has these curly braces, so we know that this is a dictionary. So this is how we create dictionaries. We can also create dictionaries with the method dict. So I could create my dictionary equals to dict, and here I can pass a list with the pairs of keys and values. It can be with tuples or with another list. So this could be another way to create dictionaries. Now the second element and the third one. So if we check now my dict, we can see that it's the same. So those both methods are equal. I prefer the first one, it's more simple, but you can use also the second one. Okay, so let's see a useful example of what can be the use of a dictionary. So imagine that we have a shop and we have the items of this shop. So let's create the items dictionary. And in our shop, we can have, for example, shoes. We can track the inventory of our shop with a dictionary. Let's say we have 45 shoes. Then we have trousers. So we have 10 of them. And finally, we have shirts and we have 60 of them. Okay. So this could be the inventory of our shop, for example. So this dictionary is quite short, but there is a good way to write them, that is separating every element in a single line. So then it's more clear. So if we had not 3 but many more elements, this would be a better way to visualize them. This runs the same way. Okay, so now we have created this items dictionary, and if we want to read them, so if we want to get their values, we can do it similar as we were doing it in lists. But here we don't have to put the index of the element, but its key. So let's put shoes, and now we have here the content of the variable shoes in our dictionary. So this is the way that we can retrieve some of these values. The same, if we want to know how many trousers we have to put the key of the trousers. And we have 10 trousers. Okay. Also, a very interesting thing about dictionaries is that we can get all keys of our dictionary with the method keys. And we have here a list of our keys in the dictionary, and in a similar way, we can retrieve all values with the method values. So with the method keys, we have our dictionary keys, and with the method values, we have 45, 10, and 60, which are the values of our dictionary. So with this method, we can do a for loop of our items in our dictionary. For item in items keys. So every item will be shoes, trousers, shirts, will be every one of our keys in our items dictionary. So now here we could, for example, print item. And now here we could access for every item its number of elements calling to every one of the item keys. So if we run this, we can see that at every loop of our for loop, as we are accessing to every one of the keys of our dictionary, and we are printing how many items it has this type of item in our shop. This is one way of accessing to every key and value of our dictionary. Okay, so now if we want to change some values, so if we want to update values in our dictionary, we can do it in a similar way as we were accessing them. So items with the key of the value that we want to change. So our value shoes was until now 45. So imagine that we sell 5 pairs of shoes, and now we have 40 shoes. So let's see how this changes. Let's print here shoes. So now the shoes are not 45, but are 40. We have changed the value here. In a similar way, if we only want to add or subtract or multiply, we don't need to change the entire value, but we can add 2 with the plus equal sign. Now we see that we have 42 shoes. Okay, so now if we want to delete some elements of our dictionary, we can do this in different ways. Imagine that we want to delete our shoes items in our dictionary. Imagine that we no longer sell shoes, so we don't want to have our shoes item in our dictionary, so we can do this with items pop. Also, again, similar as this, but here again we have to pass here the key of the element that we want to delete of our dictionary. So now it returns also the value of this element, but if we print here now our dictionaries items, we see that there are trousers and shirts, but there are no shoes, so we have deleted them. We can also delete items in our dictionary in some other ways. For example, we can use the command del that as delete, and pass then our items and the item that we want to delete. Let's say trousers. Now if we do this and print again items, we see that there are no trousers now, only shirts. And finally, we have another method that will delete all elements in our dictionary, and it's calling items and clear. So this method will leave our dictionary empty. We can check it. So items is still a dictionary, but it has no elements now inside it. Okay, so let's put again our items back in our dictionary. Okay, I have run this again. So now I declared again items with all these items that we had before. And now we can check that they are again here. So if I run items clear, you can see that all of them are clear. Okay, so more or less these are the basic concepts about dictionaries. Let's put this together. So in Python, we can use dictionaries for many different uses. Some of the most common are, as we saw here, to save the data of a shop, for example. But I put here some examples. For example, we could represent the data from a structured database, like a SQL database, for example. We could have here every element of our dictionary. It could be a column of our database. So for example, we can have here the days column, which is in this case is like the key of our table, and every row could be represented as an element of this list. So we could have the column day with the day 1, 2, 3, and 4, and for every one of these days we could have the column temperature with the temperature from the first day, the temperature from the second day, the third, the fourth, and the same for wind and precipitation values. Then we could pass this information to more advanced ways to represent this data as pandas, that it has these data frames, but this is some more advanced concept that we will see in future videos. And we could also represent semi-structured data, or NoSQL also is said, as a user's database. As an example, here we can see that we have the ID of this user and we have its name, age, email, and website. But for this other user with this ID, we only have the name and the age, and for this one we have the name and the address. So this semi-structured data, we have different attributes for the different elements of our dictionary. So these are some flexible examples of what dictionaries are capable of. Here you can see that every element stores information in a list and here in a dictionary. So we can nest as many of those as we need, and we can access to them. For example, let's access to some of these items. So in our weather database, we can access to our days information like this. And as this is a list, we can access to the first day as this is a list now, it's not a dictionary, so we have to access to the first element with the index 0. Now this is the first day, and if we want to know the temperature for the first day, we can change day by temperature, so the name of the column, and then we will be accessing to 21 degrees, which is the temperature from first day. And then we could also access to the wind information with the wind key, or precipitation the same way. So we could, for example, create a for loop here for every one of our keys and for every one of our days, and access as we want this information. In a similar way, but a little bit different, we can access to every one of our user information now with the user's ID, also here not weather but users database. And now if we print this, we see that we have the information from this user ID. Now, if we only want the name, for example, we can access here with the nested dictionary, and with the key name, we have only the name of this ID. The same way as we have name from all users in this example, if I change here the ID for this other user, we have here the name of this ID user. So these are some examples from some possibilities of using dictionaries in Python. But in today's example from the Outline of Code challenge from today, we'll be using not to store information, but to store logic of our challenge, as we will see. So this will allow us to put as the key the inputs of our problem, and we will be storing the outputs of every one of those inputs in memory in this dictionary. So we won't have to compute every time this logic. It will be stored in memory. So we'll be occupying a little bit of this memory, but we won't have to calculate every time these inputs. We'll see this in a short. So let's start now with today's Advent of Code challenge. Let's put here another Markdown title. So the day 2 challenge is about, as we can see in the title, is about rock, paper, and scissors game. I left here the link of the challenge, and I will also put the title now in this Markdown cell. Let's put it like this. Okay. So the challenge is about the rock, paper, and scissors game. So we are playing against some elves in the rock, paper, scissors game, and they passed us a list of every game. We can see here the input. Let's get it. So we can see here the first letter is the elf's hand, and the second letter is our hand. So A means rock, B means paper, and C means scissors. Let's put it here in a comment to make it clear. These rules are explained here in the today's challenge game, so you can read the whole story and to understand what it is about. But basically, the first hand is the elf's hand. So from the elf hand, which is the first letter, A means rock, B means paper, and C means scissors. And from our hand, which is the second letter from every one of the rows. So every line is a hand. It's one round of the game. From the second letter, which is our hand, X means rock, Y means paper, and Z means scissors. So it's ABC, X, Y, Z, as you can see, rock, paper, and scissors. And the score of the game is, if we lose, it's plus 0 points. If it's a draw, it's plus 3 points. And if it's a win, it's 6 points. The rules of the game is rock wins against scissors, paper wins against rock, and scissors wins against paper, and draw is when they are the same hand. And also we have to add to our score that if we throw a rock, we have to add 1. If we throw a paper, we have to add 2. And if we throw a scissors, we have to add 3. So the score is the total sum of our hand plus our result. So for example, if the opponent has a rock and we have a paper, we win. So it's plus 6 for us, but we also have to add 2 to this because we throw a paper. So it's our hand plus our score. 2 plus 6, this will mean 8 points of score for us. So the first line, for example, it's C and Z. So C means that it's a scissors from the elf hand, and Z is scissors from our hand. So this means scissors and scissors. This is a draw. And we also have to add 3 because we throw scissors. So it's 3 plus 3. This means 6 points in total for this line. And we have to add the results from all of these lines. You can see there are, I don't know how many for now, but there are hundreds or thousands of hands. So we have to automate this logic. So let's copy our input of today's challenge with Control A and Control C as usual. Let's create now in our data input folder inside it a new file, the day to input txt file. Let's paste it here, Control V. Control S to save it, so we can see that there are 2,500 rounds of the game. Okay, let's close this. So these are the rules for now, and we have to sum how many points we'll get after all of these hands that they say there. So we have to do now with open the path to our file, data input folder, and day2 txt. Okay, I did here an error. Rename because I put an extra T here as F, and this will be input row equals to F read. Okay, now we have our input here. Let's close this for now. So we have here our input row. I made another mistake here, input row. Okay, let's visualize it. Input row. So we have here the raw string of this file. As usual, now what we can add here is that our input is equal to input row split by the new line character. Now our input will be a list of every one of these hands. Okay, so now we have in this input list, every element is one round of the game, and this is the elf hand and our hand. So we could solve this with a if-else statement. For example, this could be a valid way to solve this challenge. For example, creating an if-else statement. Let's create it just to see it. Okay, so I quickly created here the logic with if-else statements. So we could create our logic with if the elf hand is an A and our hand is an X. Okay, so we have to add one because our hand is an X. Let's copy these rules here to have it near to us. Okay, so here it's the points from the hand that we throw, and here we have the points from our result. So here we have a 1 because X is a +1 for us, and as it's A versus X, A is rock and we throw a rock, this is a draw, so this is 3 points. So we have 1 point from our hand and 3 points from our result. This is 1 plus 3 is 4 points. Then elif, if we don't throw an X but we throw an Y, so we throw a paper. This is paper is 2 points for us, and we will be winning because this is a rock versus our paper, so we will be winning. This is 6 points, so this will be 8 points in total. And we could repeat this with all possible hands. So A, B, and C of the elf will have its nested if elif statement of X, Y, and Z for every case, X, Y, and Z, and X, Y, and Z. Everyone having different results. I have to correct this because I have it wrong. This 6, 0, and 3. Okay, so we should check every one of these situations, what happens when elf has a B and we have an X, Y, and Z, and update these roles, having the first as our hand points and the second as the result points. So this would be a valid way to do it, but today we'll learn how to do it more simple and also faster. In this case, this is so fast to run for Python, it's only a couple of if conditions for every one of those, but there is a faster way to do this and also more simple with dictionaries. Let's copy these rules again and let's solve it in another way. So we will store these conditions in a dictionary. We can do this in the following way. So we will create our rules dictionary, and this will have for every one of the possibilities. So we have in total, for every one of the 3 possibilities that the elf has, we have 3 other possible responses to that hand. So this is 3 by 3, this is 9 possible situations. We will need to have 9 possible combinations of hands. So this is A and X. This will have some points. Then we have A versus Y. Then we have A versus Z, and the same for the other hands. So every one of those will have different points. I'm putting it like A space X because it's the same format that as we are receiving these rounds of hands. So we will be reading this list as we have it in our input list, and we will be passing the rules to this dictionary. You will see now in a moment. And now we have to put here the points for every one of those hands. Those will be the same as we had here. So as you can see, when the elf has an A and we have an X, similar as we did here, if elf has an A and we have an X, this 1 plus 3. So we have 1 plus 3, 4 points in this situation, and the same for A versus Y and A versus Z. 2 plus 6 and 3 plus 0. This is the same points here. And we will repeat now this for the other hands. So now, as you can see, this is B versus X, B, Y, B, Z, and the same with C. Similar way as we did here, but as you can see here now, we have the same logic compressed in a very shorter space, and we put here some extra spaces for readability and putting every hand in a single line, so we could have it even more compact if we don't want to have a better readability. This could be even more compact, but let's make it more clear this way. So as you can see now, in a very few lines we have the same logic, and also now for every line we don't have to check every one of these hands if it's an A and then if it's an X, and then adding this result. We have this logic compressed in our dictionary. So now the logic of our program will check the line, and if it's AX, it will go straight to this result of here without having to check for every one of 11 hands what is our hand. This will be straight. We have stored this logic in the memory of our dictionary. So now that we have the logic compressed in this dictionary, let's see an example. So let's say the first one, for example, let's copy it from here. So the roles dictionary with this case, this first line, let's run it, and the result is a 6 because we have C that it was scissors versus scissors also. This is C versus Z is 3 plus draw 3. So this is a 6 for this case. So now that we have this logic compressed in this dictionary of here, we can create now a for loop to solve the challenge. Let's create a for loop here for round in input. Let's see what's this round again. So this is the first line of our input. So we will receive for every round, we will receive these strings, this C space Z, for example. And now let's create here a total score to store the results as we go through them. Total score will be 0. So now for every round, we want to add to the total score, add to it the rules of this round. So as we saw here, this means that for every round we will be passing these characters to our input dictionary, and it will return the score of this round of every one of those. So now this would be the result of the first part of the challenge, this total score. And this is the result. Okay, so it went through all 2,500 lines of our input, so every one of these rounds, and it has been adding up every one of the hands result to the total score. So let's see this result, and yeah, it's the same as I had with my exact input. So yours will be different because you will have a different input here, but as you can see with my input, it was 14,264, and this was the same result as I had. So that's the correct result for my case. Let's put here the comment of the part 1, because now we will start with the part 2. So this was the part 1 logic. Okay. So now let's see the part 2 that is similar. So now in the part 2, if you read this added story here, they say that everything is the same, but now the only change is that the second letter is not our hand. Let's make it larger. So the second letter is not our hand, but it means if we have to win, draw, or lose. So the first letter means that the elf throws again paper, rock, or scissors. But the second one is not our hand, is our result. So X means that we have to lose, Y means that we have to draw, and Z means that we have to win. So now to solve this, we'll apply a similar logic. We only have to change the content of our dictionary, so the logic stored in our dictionary. I made here this comment with a sum up of the new rules. So now A means again rock for our opponent, our elf, let's say. B means that he throws a paper, and C means that he throws a scissors. And now our hand is not represented by any letter, but again, if we throw a rock, it's a +1 for us. If we throw a paper, it's a +2, and scissors is a +3. But the result now is stored with the second letter. So X means lose, so we have to add 0. Y means draw, we have to add 3, and Z means win, we have to add 6. Similar as before, the only thing is that now we have to change the logic to comprehend these new rules. So let's create here a dict of rule 2. And now, for example, if we have an AX, this will mean that, okay, the elf throws a rock and we have to lose. So if the elf throws a rock and we have to lose, this means that we have to throw a scissors. So this will mean that if we throw a scissors, this will mean 3 points for us plus 0 because we will be losing. So in order to lose, we have to throw a scissors and we will lose, so we have 0 points. Let's see the next case. So now it's a y. So this means that the elf throws a rock again and we have to draw. The y means draw. So this means that if the elf throws a rock, the only way to draw is throwing another rock. So this means that we'll throw a rock, we'll have +1 from our hand, and we'll be drawing. So this is 3 points from the result. Okay, let's see the last of the A cases, and it's the Z. So now this means rock from elf, and we have to win. So this means that we have to throw a paper, and if we throw a paper, this is a +2 points for us, and we will be winning. So this is 6 points of the score result. Okay, the same for the other hands. So this is the logic now with all hands. So these are the paper situations from when the elf throws a paper. So this us losing, us drawing, and us winning for every paper situation, and the same with the C. And then the other part, so this is the new logic, but this was the only thing that we need to change in reality, because now this dictionary comprehends the new rules of the meaning of every one of those rounds characters. So now we can do again the same loop. So we will have here total score 2, and the input will be the same. The rules will be the rules 2 now, and we have to print the result 2, and will be the total score 2. Now we'll be again doing a for loop. So we'll be taking our input of strings as before. Every round will be the same again. And when we input now these strings in our rules too, we'll have these new scores with this new logic that they told us in this part 2. So let's run this. And okay, I need also to put here a 2. Let's see it now. And we have this result here. Let's check if this was the same result. And I had a 12,382. So yeah, it's the same result as I have here in this logic, so this is correct. So this has been how we solve this day 2 challenge with dictionaries instead of doing more complex if-elif statements. As we could see, this has a more compressed logic, and also this way of solving challenges is faster. So maybe we spend more memory because we have to store every one of the possibilities that we can have. In this case, is the space of possibilities is very low. It's only 9 cases. So if we had thousands of them, it would be possible, even millions maybe, but maybe if we have more than millions, there is a point that we don't have enough memory to store them, so we have to compute every time. But if we can represent every input as a key of our dictionary and compute only once the result, this is a way of memorization. So this is a way of computing these things faster. In this example, we didn't need it really. We could do it like this, but it's been like maybe more simpler to represent it. But it's a perfect way to understand a very easy case of this and be able to apply it to more complex ones. So now here it's not the repository of the advent of Python. This is my personal repository for the advent of code. And here you can see that for today I solved this challenge almost in the same way. So there is not much change. It's a very simple solution as we did before. The only change maybe it's here that I didn't develop the for loop in a separate line. So I did here the list comprehension with the for loop inside it and then the sum of it. So in a single line I did all the total score loop and addition for every one of the lines of the input. That's the only change. But the other things I did in the same way with the dictionary, storing all the logic from the first case and the logic from the second part of the challenge. And yeah, that's the way I did in day 2 of the challenge. Also, let me mention that to understand better dictionaries, so this is a more advanced concept, but if you are guessing why Python is looking faster into dictionaries keys rather than going through if-elif statements as we did here, so when you pass a key to the dictionary, it's not looking for every one of these a space x elements, but it's hashing when you create a dictionary with keys, it doesn't store the values really in the keys, but in the hash value of each keys. So this is a more advanced concept, but just for you to know. So it's not really storing in memory this string of here with this value, but it's storing this hash of here. So this is really as an index of a database. It's an integer, so as it is storing these values with these hashed values, it's so fast for Python to look for them. So this was only a small comment that I wanted to make for those of you that were guessing why it's faster for Python to look for values in dictionaries with keys and not with if-else statements. So that's all for today's video. I hope that you learned something more about Python, especially about dictionaries that are a very helpful tool of Python, and you can use it in many different scenarios. So this is a key concept of Python. They have maybe some more methods, but we see the most important ones and most of them. So you can expect them having a little bit more of methods and possibilities, but I hope that you understand the basics of them and you see here some examples. So we can store data, but we can also store logic of our program to run it faster. So I hope that you understand most of it. Practice makes it understand you better. Also, don't doubt in making any comments or questions in the comments of the video if you have any. And let's see you in the next video. Bye bye.